Good morning, everybody. I found something online that I'm kind of excited about. Let's see if it works. I have to go to the tube. Oops. I don't know how to make something bigger.
3 is a magic number. Yes, it is.
What do I have to click on?
It's a magic number.
I did something wrong. You told me wrong.
Click on the X.
Well, this is like confusing now. Okay, let's try this again. Oh, this thing, I bet.
3
Is that better?
is a magic number. Yes, it is. It's a magic number. Somewhere in the ancient mystic trinity, you get 3 as a magic number. The past and the present and the future, faith and hope and charity, the heart and the brain and the body give you 3 as a magic number. It takes 3 legs to make a tripod or to make a table stand. It takes 3 wheels to make a vehicle called a tricycle. Every triangle has 3 corners. Every triangle has 3 sides. No more, no less. You don't have to guess. When it's 3, you can see it's a magic number. A man and a woman had a little baby. Yes, they did. They had 3 in the family. That's a magic number. 3, 6, 9.
This is going to be at my funeral.
12, 15, 18, 21, 24, 27, 30. 3, 6, 9. 12, 15, 18, 21, 24, 27.
I can see the excitement. How much time do I have on this thing? Oh my God, I'm only halfway through. I think they're just doing math after this now. So we're going to stop this, so I give you work time. It's like long. And the last thing, since it's college, I have to do the Bemidji fight song because I'm wearing my Bemidji gear. Okay, I graduated from Bemidji in 1980. And so this is, imagine, the stands are completely full. It's a football game. And we're all chanting this. I'm a beaver, you're a beaver, we're a beaver all. When we get together, we do the beaver call. And talk about striking fear into the opponents. It was unbelievable. Okay, just so I share that with you. Alrighty, so let's go through this. We must have came up with the first derivative. Am I right, Carter? And what did we get here? Minus 3. So, Tyler, the second derivative with 2 primes is simply the derivative of the derivative. So now I'm going to take the derivative of this. What do you suppose that is? 12x squared. Ooh, is it minus 3? Yeah, as much as I like 3, it's got to die because it's a constant. Okay. Hannah L, that's the third derivative because it's got 3 primes. What do you suppose that would be? 24x. Now, Hillary, because we get sick of primes, when we get to 4, what we do is we put a 4 here in parentheses. Does that mean the 4th power? Okay. Zoom out. Okay, thank you. That better? Yeah, once we get to 4, we're done. Sometimes you see the 3 with 3, but it's not raised to the power. They put in parentheses like that so you know it's a derivative, Hillary. Okay? What would that be? Okay. Now, Ryan, the rest of the derivatives from 5 to infinity are what? for every single one. Okay. So if we have a polynomial and keep taking the derivative, eventually they die. Cullen, we did the first derivative. Did we write that down? What did we get? Negative, I bet. Brady, the second derivative would be what? Yep. Plus 8. What happens to the 1? What? It dies. Good terminology. Third derivative. All right, Hannah, you were gone, but do you think you can get it or not? X to the third is correct. 20 is wrong. How about a negative 40? Do you see where I get negative 40? Okay. What happens to the 8? It dies. So the fourth derivative would be what, John? X squared. And Maureen, the fifth derivative is what? And the sixth derivative, Sawyer? Okay, Gabby, what do you think my question's going to be next? No, it's not going to be. Here it is. What's the 700th derivative? There. Okay. A nice try. Okay. I threw you a curveball. Okay. Alrighty. Now, yeah. These you got to have memorized. Okay? That the derivative of sine is cosine. And here's the hard part. The derivative of cosine is negative sine. Okay? I'm going to do the proofs. They're on video. The last question on tomorrow's quiz is one of these proofs. Okay? You have to know these 4 things to be successful with the proof. You have to know, 1, that the limit as x goes to 0 of the sine of x over x is equal to what? 1, very good. Let me grab a piece of paper here. So that's one thing we need to know. We need to know this. 2, the limit as x goes to 0 of 1 minus the cosine of x over x is equal to what? 0. Very good. Okay? Pretty impressive. Okay? Okay, this is a throwback. 3. If I'm taking the sine of 2 angles that I'm adding, do you guys remember how to expand those? If you're in Math League, it's required. Because it's always a Math League question, right, Gavin? Yeah? And do you remember? No. I bet you, does anybody remember? It is this. The sine of A times the cosine of B plus the cosine of A times the sine of B. And the fourth thing you need to know is the cosine one. Which is the cosine of A times the cosine of B minus the sine of A times the sine of B. So here are the proofs. You ready? These are just 4 little tools I'm going to use in the proof. So here's the limit as h goes to 0. I'm going to use my definition of a derivative, the sine of x plus h minus the sine of x over h. We're going to prove that that's equal to the cosine of x. So I'm going to write the limit as h goes to 0, and I'm going to expand this. And I'm going to expand this to be the sine of x times the sine of h. Excuse me, I screwed up. The sine of x times the cosine of h. That's a mistake on my part. Minus the cosine of x times the sine of h minus the sine of x all over h. And I'm going to regroup these. I'm going to write this as the sine of x, cosine of h, minus the sine of x. Yeah, I made a mistake too, didn't I? This should be plus. Sorry. Is that what you were going to say? Plus the cosine of x, sine of h over h. So, what? Yeah. I just took this and moved it over here and took this and moved it over there. Is that okay? Okay. So now I'm going to break it up like this. I'm going to break it up into 2 fractions. The sine of x, cosine of h, minus the sine of x over h, plus the cosine of x, sine of h over h. We're almost done. 1 line left. So I have the limit as h goes to 0. I'm going to factor out a negative sine of x. That's going to give me, when I factor out a negative sine of x, that's going to be a positive 1 minus the cosine of h over h plus the cosine of x over the sine of h over h. Now I'm going to take the limit. The only thing that is changing is h, correct? So I'm going to, right here, get the negative sine of x times this limit. What is that? 0. Very good. Plus the cosine of x times that limit. What's that? What's the limit of this right here? That is 1. Like that? Yep. That work? And so this is 0, so my answer is the cosine of x. That's my proof. I'm going to do one more. I'm going to do the other one. All right? So I get the limit as h goes to 0 of the cosine of x plus h minus the cosine of x all over h. This is the limit as h goes to 0. Is that better? Okay. The cosine of x, cosine of h, minus the sine of x, times the sine of h, minus the cosine of x, all over h. I'm going to rearrange. And I have the cosine of x, cosine of h, minus the cosine of x, minus the sine of x, sine of h, all over h. I'm going to break them into two fractions. The cosine of x, cosine of h, minus the cosine of x. That's going to be over h, minus the sine of x times the sine of h over h. I'm going to take the limit as h goes to 0. I'm going to factor out a negative cosine. I'm going to get 1 minus the cosine of h over h minus the sine of x, sine of h over h. The limit of, so I get negative cosine of x times, what's that limit? Well, we said that was 0 minus the sine of x times the limit of that, which is 1, and I get negative sine of x is my answer. All right, we're going to take some derivatives. dy dx is equal to 2 times the derivative of sine. The derivative of sine is cosine. Are you done? You're done right there. That's all you got to do. Here dy dx is going to take 3 times the derivative of sine, which is cosine of x. The derivative of a minus 5x is minus 5. The derivative of 1, 0. Done. Number 3, dy dx equals the derivative of x is 1. Derivative of cosine is negative sine of x. You're done. Okay. If f of x has concavity, it is curvy, not pointy. I don't even know if pointy is a word. Okay? As you zoom in, the function appears linear. Curvy, right? Okay. And so I'm going to zoom in at 0. Everybody okay with that? So I'm going to go zoom, and I'm going to choose 0. See how it flattens out? If I zoom in again, it's really flat now, isn't it? If I look at my window, you can see I'm within a negative 0.1 and 1, and it appears flat. It's kind of like this. Have you ever been to southwest Minnesota? Have you ever been to Fargo? And you look at west at North Dakota, it appears flat, right? Because we can only see so far. Whereas if you see what the Earth looks like from the moon, it's curved, isn't it? Right? All right, look at this. Now, in case you, let me go window, let me go back to my standard here, 6. Okay, it's going to make this. Let's go to here. Now, to do absolute value on a TI, you go to math. I think you go to number, there's absolute value, X. Okay? Not curvy, correct? Not curvy at all, is it? It's pointy, right? So I'm going to zoom in. It's still pointy. So here's the function f of x equals the absolute value of x. I'm going to take the limit as x approaches 0 from the left of x plus the absolute value, x plus h minus that over, oops, I don't want this. Yeah, I do. Correct? Right? That's approaching 0 from the left. Okay? So, let's put some values in here. Okay? So, if I have 0 plus 0.1, excuse me, a negative 0.1, minus the absolute value of 0 over a negative 0.1, what would I get? Well, what's this answer? Yeah. Because I'm approaching 0. This is this form. Well, actually, let's change it like this. The limit as x approaches 0, I should have had this. F of x minus f of c. Let's use this form over x minus c. Okay, or x minus 0. So let's do this. Let's cross this out. Let's look at the limit as x approaches 0 from the left of the absolute value of x minus the absolute value of 0 over x, okay? Which is simply the limit as x approaches 0 from the left of the absolute value of x over x, okay? That'd be better, okay? Forget that I wrote this. So let's put some numbers. Let's put a negative 0.1 in here. What would I get if I had the absolute value of a negative 0.1 over a negative 0.1? What is that? Negative 1. Would you agree? So if I put a negative 0.01, the absolute value, over a negative 0.01, what would it be? Negative 1, correct? Now let's approach it from a right. 0.1 absolute value, over 0.1. 0.01 absolute value over 0.01. What do you get? You get 1, don't you? So as you're approaching from the left and the right, they're not headed towards the same number, are they? If I look at absolute value, it looks like this. The tangent line here is right here. It coincides with that line. The tangent line coincides with that line, correct? What's the slope of the tangent line over here? It's a -1, isn't it? What's the slope of this line? It's a +1, isn't it? Here's one more version. Are you ready? This is the same graph. If I'm graphing this, I'd have an open circle here, and y equals a -x is that line. Would you agree? If I graph this, now I close that open circle, and here's my graph. Isn't that the absolute value? Would everybody agree with that? Now I'm going to take the derivative. So I'm going to take the derivative when x is less than 0. What's the derivative of a -x? -1. Awesome. When x is greater than 0, what's the derivative of x? 1. So the graph of the derivative looks like this. If I'm going this direction, it's a -1. If I'm going this direction, I guess it's never equal. Yeah, it is like this. It looks like that. The derivative is a jump, isn't it? What does that mean? If you come to a sharp point, you can't take the derivative at that point. If you come to a sharp point, you can't take the derivative at that point. At any sharp point, it's got to be curvy. Does everybody understand that? If you can poke your eye out on it, you can't take the derivative on it. If you just get a black eye, it's okay. Last page. Nope. So on here, that's what I was saying. The limit as x approaches 0 from the left of the absolute value of x over x is not equal to the limit as x approaches 0 from the right of the absolute value of x over x. This one said all differentiable functions guarantee continuity. So when I say it's differentiable, you can take the derivative at all points. If you can take the derivative at all points, it's continuous. You're guaranteed. However, not all continuous functions are differentiable. Here's a continuous function. It's not differentiable here because there's a sharp point. Here's one that they love to give you. Here's a graph. It's continuous, correct? Right? But you can't take the derivative here and you can't take the derivative here because they're a sharp point. Here's continuous, but it's not differentiable at that point. Okay, here's another one. It's not differentiable here, is it? It's not continuous either. Okay, is that making sense? So here are my examples of continuous functions that are not continuous. Okay. Is that it for notes? All right, we're done.